Kia ora, good evening. Welcome to one more session of Code Night New Zealand. And tonight I am here to be your uh, well, to be your presenter and also the guest of this session. And we're going to be talking about something that I've been doing for a year, more than 1 year, and I have shared this session on the user groups, but nothing was recorded really. And just decided to bring this to the user group because it feels that other people can benefit from it. I think there are really good insights in here that is going to be applicable to your studies and at your work. All right, so I'm going to be talking about like building scalable Kafka streaming data pipelines with Azure Functions. Right, so we're going to be talking about data streaming. I'm going to be bringing some examples in .NET, in Java, just because, we're going to be handling data streaming with Azure Functions, right? So that's really, at least like for me, it's a really exciting topic. Really being, well, I've been having like really good fun with that. And tonight I want like just to share this with you guys. So if you have like questions along the session, please feel free to bring those questions onto the chat. And yeah, I'll do my best just to have a look in between the presentation and the comments. But yeah, I'll keep an eye on that. Before we get to start, right, I would like just to share a little bit about me. So tonight I am the guest. For those that don't know me, my name is Marcelo Medina. I'm a software developer, Azure specialist. I'm a playground enthusiast and coder. I helped like creating this site playgokids.com. That if you jump in there, you're gonna notice that's a mobile app created like for families with kids. So you can give it a go and download and see if that works for you and your family. I'm also practice lead at Datacom, and my blog is tech.playgokids.com. And I'm a Microsoft MVP, and as you can see, that's my QR code that's available um, if you're like interested in get to know a little bit more what I've been doing. Also, like would like to tell a little bit about us, the Code Night New Zealand user group. We're a community group of developers. We love coding. We follow best practice on software development languages and technologies. In general, we are more focused on the Microsoft stack, but we are open to all technologies, really. And the intent of the user group is to enable developers with practical knowledge to excel and launch their careers. So you're always going to find good content in here, right? And that you can make use at any stages of your career development, right? So I think like you're always going to make good use if you want to from the sessions that we have. And also like invite the community to come, and if you're keen to speak and share like something, feel free to ping me onto like those the QR codes, and yeah, and then we can chat about it. I'd like to mention that we're part of AzureTire.com. We're a cloud native group of enthusiasts where we get to share the latest and greatest on the cloud native space. Also, we're sponsored by .NETFoundation.org, which is an entity that looks after the different open source .NET projects. And JetBrains, software tooling for developers. Okay, with no further ado, we're gonna jump in here like to the session, and it's gonna be a mix of like fundamentals and demos. For all of you, if you are familiar with my sessions, in general, like I really like demos. Right, and from there, like we get to learn lots by checking codes, and that's what I'm planning to do. But before we jump to that, let's check like some fundamentals in here. Right, so with the Kafka, uh, data streaming with Kafka on Azure Functions, we're gonna look like the mechanics, what happens behind the scenes, right? So I think it's important for us to understand like how it works. So I'm going to be talking about a little bit about that. Kafka extensions, what's available for us to make use of them, right? So we have a lot of options in here. Hosting capabilities, where can you run your Azure functions? There are specific plans available for that, right? Not all plans, specific plans that you can make use. And Kafka data pipelines. We're going to look how we can create our production ready pipelines. I'm going to bring more um, an overview of what can be done. For sure, that can be extended, but at least like I want to indicate how you would implement that in production, right? And just starting here, behind the scenes, right? What we have with Azure Functions. So when we look at the functions, right? Yeah, not sure if you have like much experience, but basically you have like this concept of triggers, things that happen behind the scenes, and when you're handling through codes, you're basically handling those events that happen, right? But behind the scenes, there are a lot of thoughts that was put by the Microsoft Functions team, where they basically uh, handle a lot of complexities, right, around like the data streaming flow, right, and how, for example, if you have like a lot of data coming, right, how you're going to handle that if you like the throughput, if you are not being able to process all the events, would that like simply explode? You would like have like some smarts behind the scenes to identify that you're not consuming those events at the time that's expected. So there will be some handling, buffering behind the scenes that you don't even need to worry about. So things like that makes things easier for us developers, right? Not only like from well the consumption, but at the scaling as well, because if with Azure Functions, well, you could pay like for scaling, right? And you could have like automatic rebalance of events, how you consume those events. The more you get, the more it scales automatically. So those are really good, cool things. I would say that Azure Functions helps us with. And I'd like to show like the behind the scenes. Okay, so when you look like the Kafka, we have like brokers. The server is composed by single broker, multiple brokers, right? That's something like we're not going to approach how it works, but you can imagine that, okay, the Kafka server has a broker that's pushing those events to the Azure Functions host, okay? And when it gets like the host identifies that, okay, there are events coming, how does that work? So internally, we have like what's called like this Kafka listener, and that's responsible for pulling basically the events coming from the broker. After like that happens, right? So this message, these events come through a channel, and the channel makes those events available for us developers to handle directly on the functions, right? And the function here, like the block in blue color, is where our code is. We're going to implement and handle things in there. But we get like for granted what's behind the scenes in there, the channel, the listener. We can configure those, right? So we have flexibility to do that. But like this is just like a view that there was a Microsoft engineer called Tsuyoshi Ushio. He shared like on this blog post that I'm sharing here on this presentation, and he made it available like for us to understand like how it works, right? And there are like much more to it. I just want to show like some use case or what's available, what we can handle through, for example, there's like the single mode like handling, where you're basically handling single events, right? So when you think about the broker and you have like an event that's being received, well, what's going to happen is that the Kafka listener is going to try handle pulling all of those events from the broker, but they're going to be processed individually, right? And these events are going to be triggered individually. We also have like another mode, which is the batch mode. In general, with data streaming, that would be like the default. All right, so you would be leveraging this as much as you can because of throughput, and you can handle like more like events at once. But thinking here, we have like two events, one and two. They would be coming in a batch, and then you would trigger the function, and you could handle like these multiple events altogether. Okay. Uh, if you are, if you have been playing with data streaming, I brought like this video just to amuse you, because you're gonna notice something here that is about fine tuning, right? You're probably not gonna listen to the sounds, but what you can see in there, that there's a flow, a stream happening, and things are just continually flowing, right? And well, you could imagine here like different scenarios, right? What if like you have a um, lot of events happening, right? Would like this simply overflow the uh, what we have within Azure Functions? Definitely not, right? But like it, I guess like it makes you think about this constant flow and how you should think about tuning your configuration, right? So you can have that continuous flow. Azure Functions allow you to do that through configuration JSON file, where you have like these settings. I put like just a sample in here. They're completely random, right? So they're not aligned to environments or the needs of what you may require, right? So that's something that you need to put like some thought around that. How many events you're going to be handling on a batch, for how long like you're going to be pulling those events from Kafka, and how you're going to be pushing that to the functions, right? Because the more you receive with the listener, how you're going to push those to the channel. You have options in here, right? There are many more. They are based on the Kafka DLL that allows you to configure those settings. There are like details available like on this link if you want to further explore. But what I want to show is that like where, based on those configuration settings, where are those represented on the diagram that we had before, right? Here, like we have like three events being received. So what I could just dictate, well, this is my batch, max batch size of 3. Okay, I'm gonna be receiving that on my channel. And that would be like a specific setting. We could specify the subscriber interval in seconds that dictates, okay, how fast the Kafka listener is going to be pulling or consuming those events from the broker. We could specify the number of channel, right, the channel capacity. It's interesting about this one because the more channels you have, the more memory you consume, but the more events you make available for the functions to be triggered, right? So if you're thinking about scaling, you need to think about, okay, uh, about like balancing or the setup. For you to be able to do that properly, you should be doing like some sort of performance testing, right? Validating this with your team because it would require some sort of validation, right? So depending on the throughput you want to achieve. You have like this max pull interval in milliseconds, right? Where, for example, when the function gets triggered, for how long, that's basically a timeout, but for how long you want to wait for this message, for these events to be processed. Let's say like you're consuming this event and you're going to be delivering to another external system, right? let's say if we're delivering that to an API, when you compare things that happen on Kafka, they're happening at microseconds, right? And when it gets to an API, we're talking about milliseconds. So there's like a difference in there, like in time, in execution. If your API like just take 30 seconds to execute, so during like those performance tests, you need to think and consider that, right? So the max poll in here like tells that, okay, I'm gonna wait for this period until I try again, right? So it's basically I would consider this as a timeout configuration. But you have like, as you can see, I just put like some sort of settings here like on the diagram for you to have an idea. There are many more, really. Uh, if you're familiar like with Kafka and when you're configuring like consumers for that, yeah, you have tens of like configurations if you want to use. There are, I always forget about this one. In the channel full retry interval in milliseconds. That's basically like how many times like or how fast your channel is gonna be pulling, right? Because you have the listener that pulling for on the broker, but you have the channel as well, grabbing what's available on the listener. That's yeah, you have like full control on things. Uh, when I think about like the scaling, not sure like how familiar you are with Kafka, but for in Kafka we have this concept of topics. That's a topic basically is going to hold events, and those events are going to be associated to partitions. A partition is basically um, I would say it's how events are stored, but how um, Kafka determines like where to put the message, the event on the partition is based on a hash, an algorithm that's part of like the part of Kafka. But you can control that if you specify the events containing a particular identifier. If you have like the same identifier, you're going to make sure that it goes, well, Kafka is going to make sure that it goes to the same partition. So you have controls for that. I'm not showing here because this is out of like well, it requires like another session, like on Kafka 101, for example, right, to understand how it works. But like that's how things work within like the topics. But as you can see here, like on the function, right? Let me bring my pointer in here. But you have like this worker, right? And this worker has a function. So it would be like our implementation of the codes. And we have like this yellow mark that represents a consumer group. So when like the topic on Kafka is created, uh, if you don't specify a consumer group, there is a default one that's assigned. But let's say that well, what's nice about uh, Kafka in itself is that when you're putting like a specific event to a topic, you can have multiple consumers. Let's say you want to deliver a specific the same events to a system one, and then to a system two, or a system three. Uh, well, you could define more consumer groups. A consumer group could be a representation of a particular system, right? So you could have multiple consumer groups. Here I'm just showing that if you have like only a single function, that's going to be on a single worker, it's going to be automatically, Azure Functions does that for us. You just tell the consumer group and the function hooks onto the topic partitions, right? So you can see here by the red lines. If you have like an increase of those events, right? Let's say things are getting really busy and there are more events coming and you set up the function to scale. What's going to happen is that the function is going to start scaling and the balance, so like when I say the balance, is that the function, the host, is going to automatically reconfigure how the consumption is going to work because as you can see here, for example, partition 0, 2, and 4 are associated to one worker. but 1, 3, and 5 were associated to the other one. This is completely, uh, well, it's resolved for you. You don't need to think about it within Azure Functions. That's the rebalancing thing that happens behind the scenes, which is amazing. So you basically just code it, and you have like this whole rebalancing mechanism embedded within Azure Functions. And when you get like to the max throughput and have allowed the Azure Functions to scale, you're going to end up like with multiple workers, right? Until you get to the point that you have like a specific worker associated to a partition. That's what would happen, okay? That would increase to the max number of partitions that you have. And they're like, okay, cool, that's what you want. But there are ways of well, if you think about costs, right? So you're gonna pay there like for CPU, for RAM, memory. Each worker is going to consume like minimal sort of RAM, right? Uh, you could think, okay, how can you optimize that? You could combine functions, right, into a single worker. Azure Functions would still like handle and rebalance things uh, seamlessly, really. So when you think about that, is that you would end up rather than six workers. And here I put like an example of three. So what I have done is that on my trigger, I'm going to show on codes, but on my code, I have two triggers implemented by the same rep of the functions, right? It's not like a method. I have two methods. And then I have like cost savings because I have less workers, meaning that I have less memory being used for that, okay? To the point where when you compare things, if you were to have six workers, you would have CPU and RAM associated to that. In here, you have like a bit less, right? So you have cost savings. If you have like multiple consumer groups, right? So we could like have like multiple ones by like consumer group A or B. As I said, like systems, system one, system two. And the rebalancing thing, like I'm showing with the lines in here in red and blue, Azure Functions are going to handle that for us, right? So, which is pretty cool. How the events are consumed. If you think about that, uh, there's this concept of pointers, right? So pointers that are Kafka handle, but also how Azure Functions handle that. So you can see there's a sequence in here. The first one to start. So a pointer is created and persisted on Azure Storage for each partition of this topic. So as you can see here, right, for each partition that we have on the topic, we're going to have this onto the Azure Storage. Like Azure Function is going to handle that for us. From there, on step number 2, when the new messages are received, right? It's interesting to see here like messages, right? But not sure if you're familiar, but like events, right? So events are immutable facts that happened in the past. They represent a state, right? So when we talk about events, but how physically they are represented through messages, right? But I think it's important to see that you're going to see events, messages, but events is the representation of a state that happened in the past. Physically, they are implemented through messages. Okay, so when it says in here, when new messages are received in a batch by default, uh, the host attempts to trigger the function with the batch of messages. Fine. Uh, Important point here: if the function completes the execution with or without the exception. Okay, so that's important consideration because the Azure function works with batches. If things have executed successfully or not, the pointer advances and a checkpoint is saved to the storage accounts. Have an animation here, okay? It progresses, meaning that if you don't handle exceptions, you're gonna lose those events, right? So it is important to, when you're implementing, that you consider like the HAP in alternative scenarios, exception scenarios, okay? They're here, like step number 4. If conditions prevent the function execution from completing, the host fails to progress the pointer. If the pointer isn't advanced, then later checks end up processing the same messages. Uh, it's interesting about this one here, about conditions. I'm gonna put like a link to the site, but these conditions are external to our code. There could be, I don't know, think about a data center going down, one of the Azure data centers, or anything that could happen on the data center that we're not, is not like of our concern. But there could be conditions happening in there that prevent the processing from completing. Uh, in this case, the pointer doesn't advance. As soon as you restart or the process automatically restarts, that event that may have been executed, but it wasn't committed, is going to happen again, right? So there could be a duplication of messages. So that's an important consideration as well, because I've seen articles in the community saying that Azure Functions works under the in terms of like delivery guarantee, is that at most once, meaning that you would have like a single sort of message being delivered every single time to consumers. That's not the case, right? So it's at least once. I have like summarized that in further slides, but you can expect to have duplications. So if that's something that you're not expecting on the external system, you need to design systems to be either potent, right? So where you can handle the same message again, right? So meaning that that state does interfere in the end results of what the external system is going to expect, right? So you need to handle that. In general, like with APIs, you're dealing like with upserts, where like if it's the first time it's an insert, or if it's the second time it's an update. They are like depending on the external platform, external system, you're probably gonna have that sort of handling for you. If you don't, you need to think about that. All right, and then the events continue. Right, the pointer once it's created, that flow continues. Okay. There's like this link about the functions reliable event processing. It's interesting because they put like that for event hubs, same is applicable in here. But it's good to see that, to know how it works, right? Because uh, in general, I think like the documentation, it's there are lots of content, but in, for like architects or people that are designing solutions, right? You're going to have those questions. Uh, it's important to know. I'm just saying that. I think out of this session, if you get this one, and you get to work with those Azure Functions extensions, you're going to like be advocating for best practices. Okay. Kafka extensions. They're they're available in two modules, right? So if you're familiar with functions, there are like two modules in the process, which is the legacy model that's been there for a while, and the new isolated worker model, which happens that is a separate process that is executed, right? And that's the way to go, thumbs up. The in process is thumbs down. So this is going to be further, well, the support period for that goes up to November 2026, okay? So if you are starting a new project, go with the isolated model. If you have in process model, you need to plan for a transition on that. Let me go to the slides. This documented on functions bindings Kafka. Okay. When you're setting up like those extensions, right? We have those triggers, and you need to configure those depending on the app service plan. Right? In general, like it's recommended for you to enable like the runtime scale monitoring. This is going to be crucial for premium plan, for the premium plan, Elastic premium plan. So as soon as you set this one to on, and you want like your Azure functions to scale properly, you need to have that. If you don't do it, what happens is that the functions are not going to be watching for the partitions, right? So they're not gonna scale. So you're gonna be paying for a tier that you're not gonna be making use of their capabilities, right? So make sure you take that one. That's also like available on the same page, like functions bindings Kafka. And the bindings. So we have two bindings. The first one is the Kafka trigger. In here, what I want to highlight is that, well, you have like a string in here. But if you look, oops, that's the one here. Okay. So we have like this Kafka trigger in here. And that's like the extension that we're going to be using when we are consuming those events, right? So same as I showed like on previous slides, when the events are received, this Kafka trigger is going to be executed. In here, I have just like a string, a simple string, where I'm handling a single mode, a single event. And I have like other option where I'm doing through batches. So in here, you can see that is batched is true. And I have an array, right, of strings. So we can better accommodate the number of events that in one single batch. And you can see here like the for each, right? So you need to handle that. In here, I don't have the try catch for it's a dummy one, but in your code, you need to have a try catch a higher level than this for each, right? Things explodes in here, at least like you want to handle that, okay? So, but for the context of this presentation, I'm just showing like something simple. Uh, with that, I can show like in here how it works, right? And let's go like to code. Let me come with my screen here, Visual Studio. And I have like this, oops, as soon as I can fit that in. But you're gonna see that I have like a project that I created like for a consumer, and I have another one that I created as a producer, okay? So I have like this code available. I'm gonna put like on the chat, and then you can check like yourself when you have the time. And this one would be in here. Okay, I'm gonna copy this so you can have a look later. That should be on the chats now. Okay, I'm just put like in here as well. And if I come to that, we're gonna do, I'm gonna look in here at the local settings. I think this one is okay. It's a good size, but I have created like on Azure Functions, you can disable them through configuration. In here, well, disabled, true, right? All of them is disabled, but I have like run single second, single third, and then batch second, batch third. Remember like about the cost savings I mentioned? I'm gonna show in here like what that means really. So if you look in here, I have like this run single that runs on this topic. If I look down a little other lines, I have like this single second here, but it's consuming from the same topic, right? And the third as well. So I have, well, this one here, it's my function. I would say like that's the project itself. Okay. Or let's say like on my single rep, on my single class in here, I have multiple function implementations, multiple methods. And what happens that by doing that, the Azure functions are going to trigger those methods automatically, right? And if you look in here, I have like asterisk, I have dashes, and I have equals in here, like those symbols, right? I just want to show that by creating those things, right, getting those things to run simultaneously, we are able to see that uh, the methods are automatically distributing how they're consuming those events. I want to show this one. Um, I'm conscious of the time because last time I did like this example here, it took um, quite some time. I'd say like an hour, another presentation, an hour and 45. I don't want to go that far. I want to focus like in 1 hour tops, 1 hour in few more minutes. But I'm just gonna run this all together, right? If I get to run this, I'm gonna leave this running. So this one should be executed. One thing I noticed is that my functions in here, I'm using Confluent, right? And I noticed that it has automatically logged out. Let me come back to that while you can see the function starting, right? And so you can see here that I have like a Kafka, the single seconds, and the third are executing. The other ones are disabled. Um, it's not, oh, it's running, but there are no messages, no events being received. What I want to do is just to simulate that, right? As if we had, well, the broker creating or having those events available for us. Let me just connect in here. I'm just connecting on Confluent at the moment. And as soon as I'm in there, I'm just going to show what I have. Just bear with me. And I think now I am good to bring it back in here, my screen. And in here, like I have connectors. Not sure if you're familiar with Confluence, but we have generators that we can use to push events, right? In here, like it's a connector where I'm just creating JSON like messages, and they are, I would say, random. Like they have like specific payloads, but for the context of this demo, I just want to be able to generate those, right? So right now, I just triggered, right? But you can see here that I have events being created, right? And I'm gonna pause that because, well, I think like for the context here, I think like this is like it's going to pause. I think it did now. And you can see that, well, we have in here like asterisk, right? 2600. Then before was asterisk 2598. What about 2599? That was done by the hyphen methods in here, 2599. Well, it's interesting. You can see equal 2594. So there was like a big jump, right? The 97, 96, 95, 93. Well, there you can see things there are like being automatically rebalanced, right? And what is interesting about that is that you can have as many methods as you need, and you can play with that. You should do like performance testing for what you're trying to achieve. In here, like I have single modes. If I was to do like this with like a batch, right, it would be exactly the same, but you would have more coming. Okay, so I think like for the sake like of the time, I'm going just to skip the batch. but it would be the same, really. You would have like more events happening. But it's interesting to see how that works. Actually, I'd like just to maybe trigger that once more so you can see the debug modes, right? Because I didn't put like a breakpoint. I think it would be nice for you to see like the payloads. If I put like the consumer here, and I'm gonna manually create like um, an event. Uh, let's see, things are starting on the screen. Let me zoom in, or at least increase the size of the font. Wow, single. All of them are executing. I don't have like new messages being received, but I'm gonna force that. Okay. What I'm gonna do, I'm gonna go to the topic and go to like to the private topic. What I'm gonna do is under the messages, I'm gonna produce a new message. Okay, it's a dummy. 123 is the key. As the value, I'm gonna say just like a sample. Could be anything. Okay, guys. But I just put in here a sample. As soon as I submit that, you're gonna see that this is going to be triggered. Well, let's put produce, right? It just came. So that was triggered in here. If I look at like the events data, well, can I zoom in? Yeah. So we're gonna see like I have offsets, partition, topic, timestamp, value, 123, the key coming, headers. I have everything available for me here, so I can make like have some logic or to even like convert or adapt, transform, let's say, this message. In here, like I have a like simple method that get message. What it does, if I deep dive, you're gonna see that I'm parsing. Okay, a key, a value, offset, and a partition. That's it. And return like an object. I could be handling that the way I wanted, like depend on my business logic. Okay. As I mentioned, I don't have here a try catch. There should be a try catch. I remember about the exceptions. You need to handle that. For the sake of the demo, I'm just showing what's possible. Okay. And that's it. Like just execute it and finish under the single. Interesting that like it could trigger like under the second or the third. It would be random, but I think like luckily for because I put the breakpoints onto the single, just trigger that one. But it could happen in all those. They all use the same topic. Okay. What I'm gonna do in here is that I'm gonna disable. Okay. And we're going to explore a little bit more. Let me come back to the presentation. Okay. The second extension, we have the Kafka output. This one. Okay. Kafka output. So this is basically a producer, meaning that we are creating events. Okay. Eh, what's interesting about this is that, well, if you look at this slide here, we have like a string, nullable string, but it is a string. It's a single mode, so we're producing one single event. There, we can work with batches as well, so we can produce multiple events together. How that can be done? So in here, if you look, we have, well, this is the, all right, I'm just pushing the single event. So when I'm receiving in here, if you look, I think it's better. But I have a HTTP trigger. So let's say I have a HTTP request. I'm sending like a post request in here. Oh, that's that's bad. But I have like a post request in here, and I'm going to submit a message. And this message is going to be bound to a wrap, kind of a message in here that contains offset, partition, topic. Right now, there is a, I would say, kind of something. not an issue, but something useless in here that because like the way how the messages are created, right? Maybe like it's a .NET, like it's typed, right? It's not like done as nullable, because if you provide the offset partition the topic in there, but because you have other configuration settings, they kind of override what's in there. So it feels like it's a required field, but the value itself is ignored, right? What you need really it's the timestamp, the key, the value, or in headers. But in there, like you have this type that contains the multiple output type, which is the one that I mentioned before, where we generate a single uh, message, right? That's the multiple output type. Yeah, that was just an example how we could create and do that from generating that through codes. I'm going to show like this on code, how it works, but you can see that the message that was created in there, even the headers, if you had like headers, you could embed that and have full control. We can do the same with like an array. So we can produce multiple messages, right? And everything here that's in here, okay? Well, this requested, oh, sorry, required, this required, this required, this required. This one in here is optional, okay? If you enable idempotence, it means that you want to guarantee that you get an acknowledge of the Kafka brokers, right? So as soon as you push an event, you want to know, was that received? Has failed? Or you want to ensure that that's delivered and you get an acknowledgement back. You do that to guarantee that a single event is produced. I put it here like as an example, but if you don't care about like mass events are duplicated or not, you don't need to bother about that. But in general, like from the platforms I've been working, this is important. I just put actually I forgot like on this screenshots, but it's something to consider, right? Because like when you're enabling, you want to have avoid duplications. You need to consider your producer being compatible with the idempotent and your consumer as well. Okay, just like just some insights really uh, of of the why of this. Let me continue with that. And there's an example in here where producing multiple messages, right? Events altogether using this multiple output type for batch. I created this one. You could specify any sort of naming for your classes. What I want to show is that we can do this like this. Oops, is it going? Well, so we're producing like the message. You can see we have like hard coded things, key one, value one, right? So this one is the key one, key two, value two, right? The partition offsets, they all random. So that's why I'm saying that well, you don't need that part, but it's in there. Uh, that's the example of showing like the headers, right? Before we get to this one, let me just show the producer in here, okay? It's neat. I just want to show like one example. I have just set this one to be the startup. Let me close this. I don't need for now. In here, right? Multiple output type. That's basically the screenshots. I got it for a single event. And I put like a breakpoint in here just to show how that like would work. I guess for this one is that disable false. I'm gonna put like only for the, well, this one should run, so they should be enabled already. Let me just run that. That's gonna bring another screen. Okay. And when that initialize, I'm gonna bring my HTTP client or the tool for that. So I have a post for this one. Okay, that has initialized. In here, I'm using like Thunder client, but what I'm doing here is that, okay, I'm using like the post and I have a message, hello from me. Okay, so I'm just gonna send that one. it triggered. You can see Visual Studio here is just showing. And what was the message? Right, so that was HTTP trigger. I'm gonna grab the message. What's the message? Okay, hello from me. So I got in here, that came through. And then like you can handle anyway, like if you need to massage that, change. In here, like I'm just creating like a simple event and sending this, right? 200, okay? And if I look what specific topic, in here it's a trigger, but if you look at the output type, so it's going to topic, okay? So if I look in Confluent, ah, uh, well, in here, I just received, if you notice, right? I think like what's nice, Confluence that they have this auto refresh, but you can see here that what I produced came along, okay? And if you look like the value, the key that was in there hard coded, even like the hard coded headers came across, right? So which is good. So you can see that well we're able to produce those. And I have like another one in here like the batch producer. I'm gonna show later. It's well here like we're going to go a little bit more like a production ready sort of implementation. And let me just go back to the slides in here. If that comes, I think I stopped the presentation. This one, we have retry mechanisms, and this is available in Java. Uh, in .NET, if you need to implement that, you can use poly, right? Some time ago, I had like a poly session. So if you look like the YouTube channel, you're gonna see like the poly presentation, and I show like in details how to do that in .NET. For the Azure Functions team created this for Java, for JavaScript on Node, right? So which is pretty cool. So it's all baked in, right? I had it this one on Java. I'm just gonna show what it does, but I'm not really execute. I'm just looking at time. But what's important here is that you can see that we have this fixed delay retry, right, which is a fixed retry for, well, 2 seconds. If you look in here, oops, let me just zoom in that in a way that fits everything, right? So this one, it's every 2 seconds, have a retry, right? Or I could have this exponential back off, which is interesting because then what it does is it kind of spaces the requests, the retries between, oh, can I, oh, no, I don't think it's going to go. But what I would have in here between a minimal interval, oh, where's my mouse? No, between a minimal to a max interval. So you could, oh, well, this is random, right? But it's going to space those requests, imagining that the other uh, system, right? You're pushing like you're producing. This one, it's a consumer. So let's say that if you're consuming that and you're delivering or massaging things, there's an error, you're gonna attempt to do it again, right? In spaced time. But the implementation here is just a dummy, really. What it's doing is just throwing exception over and over. So you can see how it works. The code for that, I'm gonna put it on the chat. That's this one. So if you want to have a look and run yourself, you can do that. I'm just put like here on the chat on the screen. So yeah, even if you want, like I have more really. If you go like to the repository, right, and you search for like Kafka, you're gonna see many more like advanced examples with formatters like JSON, Avro. Well, there are multiple things in here, not even leveraging Azure Functions. Okay, so I'm showing Azure Functions because kind of alleviates a lot from our concern, like as a developer. So, but there are other things in here as well. Let me just bring the slide again, right? Eh, Around the scaling, what's important to consider is that if you're going to run the Kafka extensions, you need to either run on premium plan or the dedicated plan, right? The premium plan is designed for, is event driven. That's where you have that sort of those smarts where you're going to have the host uh, just consuming those events for the topics, and also scaling based on the number of events that are arriving, right, onto the topic. That's the recommended way of doing things. There's also the dedicated plan, which aligns, it's a manual sort of auto scale. So if you think about like traditional web apps where they run on dedicated plans. So for that one, there are no such smarts where it looks at those topics and those partitions, but you can scale based CPU, based on RAM, right? They're, well, exactly the same as how you would do with web apps, okay? Uh, there are like some examples in here. Well, just links to where I got it. It's interesting like that on the premium plan, right? There, like the premium plan, there's the elastic premium plan. Uh, when you talk about the premium plan, we're talking about the elastic, right? The elastic premium plan is the ones on the tier that starts with E, right? EP something, EP1, EP whatever. It's not like just the premium, which starts with P. It's a kind of, I think that's the way how the team, the Microsoft functions or the hosting team defined the plans. The premium plan used to be like a kind of start with a P, and then they put like the elastic to become like this sort of more flexible tier. But the premium plan, if you use it with those Azure functions, they're going to behave as the dedicated plan. There are more details to that. All right. So if you want to check like the functions premium plan link in there. But you should be using the Elastic Premium, EP1, EP2, right? So just like it to mention about the scaling, what you need to have in terms of hosting. And you can see depending on what you choose, like if you're running on Windows, those are like kind of standard sort of information from the Microsoft websites. You can have like up to 100 instances on Linux, between 20 to 100, depending on the region that you are. So you have like more comprehensive sort of details on that. Code start behavior. Is that an issue? No, it's not an issue. So you could consider like either the premium plan, dedicated plan. So what happens, the premium plan, they have these perpetual warm instances, right? It's always going to be there. So if things are triggered from warm instance, pre-warmed instances, they're going to become ready instances, right? So you don't need to worry about cold start. It's not a problem. Dedicated plan, if you remember like web apps or if you work with those before, if you take the always on, so your instance is always going to be warmed up, right? So that's not a problem. For dedicated plan, you need just to enable that, but this shouldn't be a concern at all for you. That's the cold start behavior link. If you look at the service limits, it's interesting to see that, well, premium plan, you could scale from 3.5 gig RAM to 14. Dedicated plans, you have like other flexible uh, values, right? Or even like ASC, right? App service endpoints environment, sorry, app service environments, which is the sort of bubble that Microsoft creates for you, where you have security concerns all baked in. Uh, Pretty good, expensive as well, but those details in here. You can further explore that under the service limits. Networking, because you're leveraging those two plans, you have full capabilities of connecting to VNets. Right? The difference in here is just the premium plan is regional, while dedicated plan, I think it's more like for the ASC, that's regional and gateway right, mode, but you have full capabilities if you have um, uh, network, right, in working environments where you have that consideration. So fully supported. Billing, premium plan. It says in here like that this plan provides. What if I can I put in here? Yeah. Well, right. The most predictable pricing. That's true because you have those pre-warmed instances, right? At least one. If you don't configure, that's going to be there. So you know like how much you're going to be paying for that. On dedicated plan, well, that is going to depend. So if you have set up like your scaling to be like static for one or to have like more instances, yeah, it's just like variable. But yeah, providing you have considered how you're going to scale things or the minimum sort of instances available, yeah, that's you can control that and have like a full indication of pricing for what you need. Okay, let me continue on that. Data streaming data pipeline. This is production ready sort of implementation. I mean, like for based on considerations, right, from system to system, right? So let's say you have two platforms. I'm gonna mention examples like from the ones I worked on, like Salesforce to Dynamics 365. So when you need to transmit like states or transfer states from one platform to the other, could be orders, anything like that happen, or something that has happened in one platform and you want to transition that to the other platform. So let's say like a system is creating like those events. How they're gonna do it could be webhooks. They could directly call like your producers. I put like the producer as an Azure function in here. And the producer is going to be using the Kafka output extension to create those events. To where? To private topics. So with private topics, that's how you handle raw events. When I say raw, is that you're grabbing them as is, right? This could be a platform, how the source produced, like how the source produced the events, we containing like a specific contract or with like properties, right, on your JSON, and but you're grabbing as is. That doesn't mean that's ready for consumption to any other systems, right? You could have like your company on the company you work for specific schemas or contract, which are contracts defined for to be consumed, right? So in here, after like you received the event as is, you're gonna have some sort of data massage, some sort of transformation. That's why you have in here a consumer and producer using like the functions to do that. Yeah, basically, you would have like a consumer or HTTP, Kafka trigger to be executing. And then out of that execution, you would have a Kafka output extension to produce that and push to somewhere else, which is going to be the public topic. So the public topic is going to have the right contract, right? Because from consuming from the private in producing that and pushing that, you should have some sort of data transformation there to align to the contract that you expect on the public topic. Uh, and that should be the events pushed for consumption to for external systems, right? So in here, you're going to have also, okay, a consumer to pull the events and push that to the external system. Could be through API, right? Whatever. Even the producer could be like a data lake or any other like system. But well, you're only doing that for what you need to the other end. What I'm not showing here is that the contracts, those schemas, in general, like for organizations where like they have defined those contracts, you would have like a schema registry, right? The schema registry would be on top of those topics, right? And those consumers and producers would be aware of the schema registry because they need to match exactly the produce validate the contracts exactly as they match on the schema registry. They're not showing that in here, but something that you need to consider on those repositories I have shared, it isn't there, right? I have like specific handlers containing like Avro, for example, formatting, right? In here, I'm just showing like a overview of how you would do things. What about exceptions? Right, I mentioned about exceptions. I reinforce about those exceptions. They need to be handled. How are you going to handle them? With like DL queues. What's DL queue? It's just dead letter queues, right? Which are other topics. So basically, if things error, you could have like a retry mechanism, right, to attempt and deliver that event again. If fails, then you could just push to a dead letter queue and would remain there. Then from the team, the company, like operations team, could handle that, or you could have like other automatic mechanisms of watching those dead letter queues and reprocessing, replaying those messages, right? So that's a kind of a replay thing that could happen. So basically, events in there, you replay it, and it attempts again to do that. Uh, it's an important consideration, right? So that's why I'm bringing here. Uh, what I want to show is this, not the codes, right? So I'm conscious of time. That's the last demo. And the batch producer. In here, we have like disabled everything, but the batch producer should be enabled, which is the opposite in here. And what it does, right? So if you look in here, I have my Kafka output, meaning that this is my rep that's going to, well, create those events. Interesting thing here, the topic. I created like a topic called topic output, which is different from the Kafka trigger, which is the consumer that consumes from topic. All right, so I'm going to be consuming from one single topic, doing some sort of transformation, and pushing to an output. Uh, well, what's going to start is going to start with the trigger in here, my consumer. And what I'm doing here is, well, it's just, well, you can see I have the try catch under this more high level or wrapping. This is an array of events, right? So you can see it's a string array. And I have like this for each in here. It doesn't do much, but like you can see that I'm converting to a particular type, message with header, right? And what it does in here, message with header, it just pushes, like grabs the message, the string completely, parse, and creates the wrap. Remember, like what I mentioned, that's this is not required. Yeah, still there, right? So, but really doesn't make like a difference. The only thing you're gonna change key value, timestamp, in the headers. And if I look in here, like we would have like some sort of data massage, but for the context of this demo, like I'm just grabbing as is, transform to a JSON and pushing that, right? Or transforming to this multiple output type for batch, right? Which is this one, which is going to generate the message onto this topic output. Let me start this one. Right? It's a really interesting. Oops, not that actually, because I had the producer enabled. I want to do this one. So let me just start the setup in here. And now I can play it. Cool. It just came to my other screen. Let me show that. I think that that's pretty cool in here because you can see things flowing well, the more you have, the less you see. Things are so fast, really, and just printing, right? But yeah, if you have like hundreds of messages, millions, well, Microsoft has published an article about like processing 1 million messages per second. That's insane, right? So by leveraging Azure Functions, yeah, and well, you can see how crazy that can go, right? But it shows here run batch producer. And what I want to do it is that I want to go to Confluent and I want to go to connector and I want to generate. I remember this generation here. I'm gonna resume, right? What you can see before, I have like my demo topic and the demo output. Okay, so this one is going to be populated, but my function is going to consume and push to the output. That's what's going to be doing here. So if I go in here, it resume, I think it's going to show the settings in here. Let's see. Uh, Not really. Here, topic. Okay, demo private key. Dev, sorry. And let me just run that one. So it's going to be generating things. All right, so it's batching things in here, right? It's going to be generating. And what I can do, I'm going to leave it. And if I go to the topic in here, the output, messages, you're going to see things, or the auto refresh is on, right? But you're going to see that this is going to be updated. I did, well, yeah, 26, 53, that's going to be incrementing. And I'm just connecting functions, right? Consuming, massaging, pushing. So things are just creating in here. What would be nice, I think like the generator, the connector, he could maybe generate more messages at once. I didn't change like the standards on that. But you can see, yeah, things are just happening. And that's how like you would have in production, really. And that's how like you could do it with Azure Functions, okay? What I want to do is just to pause the thing. Uh, by the way, this is not free, okay? Confluent, you pay for those connectors. I'm just using this onto like a particular instance, a demo instance, but nothing of this is free. But it's a good like sort of platform, and I like using it. So I'm using it for clients, so it's pretty good. With that, let me just come to my slides. Uh, Considerations, right? This is the key points in here. Azure Functions only supports enable alt commit true. So there is like the current implementation, what you do is that we are consuming batches. As you consume, things get committed, right? So it's always that sort of balance. What if you want to control the commit? What if like you want to consume like an event, deliver, get a response, and commit that manually? That you currently can't do that. There is an issue that others in the community raised for Microsoft, where asking for that flexibility, right? But currently it only supports auto commit true, right? So the offsets are committed automatically. Offset are the pointers, right, on Kafka. They are committed automatically. Unhandled exceptions may cause you to lose messages. So executions that result in an exception will continue to progress the pointer. Setting a retry policy will delay progressing the pointer until the entire retry policy has been evaluated. So to exception handling, deliver guarantees at least once, right? So you could have duplications. That's important consideration here, okay? Meaning that our codes, independent systems, need to account, I would say may need, because if you're not bothered about duplication, fine. But you may need to account for the fact that the same message could be received twice, As a rule, every function should include a try catch block at the highest level of code. Okay, so any exceptions happening there, you have a way of handling. Part of the function's reliable event processing link. If you have the time, and if you want to help the community, and if you want to control auto commits, like to manually commit those offsets, this is an issue available on GitHub. Uh, there's like a discussion in there. But what I see, right? I think like this, there is a need for that, but there are ways of doing things through code, right? If people are not leveraging Azure Functions, they would do through vanilla. Well, I'd say .NET could be Java. You could do that, like other ways of handling it. But it would be nice to have that on Azure Functions, right? So in general, like what I see is that people are doing that and they don't notify the Azure Functions team. So please be kind if you can put like a +1 in there. Vote for this. That would be helpful and it would help others in the community. And it's going to help also the Microsoft Functions team to prioritize their focus, right? And that's the link. The QR code's in there, right? That's the link also. Demo samples, all of them, right? I put it in there. I share like on the slide. I think here like there are more. There's more examples. The ones like coming from Microsoft as well, right? And so if you come back to this, you're going to have like some fun, right? And well, with that, like thank you for sticking around. I know that we passed few minutes from the estimated time, but I guess well, I hope like this helps you like when you're doing like data streaming with Azure Functions. And yeah, let me know like how things go. I'm keen to hear like from your experiences. Ping me like on LinkedIn or even like on the user group chat. And yeah, just to let me know if you need like any sort of assistance. Like I'm keen like to be exposed like to more implementations and get to understand like the different use cases. I've done like few of them, but there's always like something different, right, to particular client requirements, which is interesting, right? Yeah, I think like we're getting like to the end of the session. We should have like more sessions coming for the year. So soon I should just publish that to the user group, but that should be coming as usual, 3 to 4 weeks. And yeah, and thank you for sticking around and talk to you guys in the next session. Yeah, thank you and have a great night. Cheers.